So from the previous classes, uh, we have learned about annealing, and today we are going to study what are the types of annealing. So you can see here there are mainly four types of annealing. Different types of annealing are used for different purposes. So here we have stress relief annealing, isothermal annealing, spheroidal annealing, and full annealing. So let's discuss all these types of annealing. So this stress relief annealing consists of mainly three steps, and these are heating the cold work steel to a temperature between 500 to 550 degrees Celsius. That means the cold work steel is heated up to 500 degrees Celsius. Then holding the component below this temperature for 1 to 2 hours. And you know, the holding of a component at a constant temperature is known as soaking. So this is a soaking period. Then after this, in this soaking period, the transformation takes place. After this transformation takes place, let cool it to room temperature. And this is the three steps constitute the stress relief annealing. Our next step is isothermal annealing. So it mainly consists of four steps. The first step is similar, but the temperature is different. Heating the steel component above 30 to 50 degrees centigrade for hypereutectoid steel. And also, I have not mentioned here, and for hypoductoid steel you have to heat up the steel component above A3 temperature that you get from carbide diagram. So then slightly fast cooling to a constant temperature, there will be fast cooling takes place. Then hold at this temperature for this transformation. So this fast cooling will helps you to give ductility, sorry, brittleness to this component. Then cool to the room temperature. So why this is known as isothermal? Because slightly fast cooling to a constant temperature, we have to slightly cool this to a constant temperature, and we will hold this at a constant temperature. So it mainly involves four steps. So after that we have spheroidal annealing. So in case of spheroidal annealing, first we heat the steel component to critical temperature, near the critical temperature, then holding at this period for a longer period of time. Then what are the grains are there, this converted to spheroidal shape. That means some cementite are forms in this state. Cementites are formed, and these cementites are very soft. Okay, these cementites are very soft, and then cool to the room temperature. This cooling is very slow and requires more time to obtain this spheroidizing structure. Then we have full annealing. So this also applied to hypotactoid and hypereutactoid steel, and for both of the two we have different temperature range. So first is heat the steel component above A3 for hypoeutectoid and A1 for hypereutectoid. It is from the carbide diagram. So now holding at this temperature at least for 200 minute per centimeter. So that means per cm we have to hold this for 200 minutes. If it is 2 centimeter, then we will hold this for 400 minutes, like that. then cooled it to room temperature. Now we have discussed all these types. Now we are going to discuss the advantages of all these processes. So you have known that stress relief annealing is applied to hypoeductoid steel containing low carbon. Then it's relieve internal stresses without any loss of strength and hardness. It increase the corrosion resistance and increase good machinability. Then isothermal annealing, it is applied to hypoeductate and hypereductate. So it reduces the annealing time. Then it gives more homogeneity in structure. So then it improves the machinability and surface finish. Generally, it is primarily used in medium carbon, high carbon, and some alloy steel to improve machinability. Then we have spheroidized annealing. It is used to high carbon and hardened alloy. So during heating above A1, cementite try to dissolve, and during cooling they try to reform. So spheroidized structure form which are very much softened, and uh, they fully anneal structure. So they have excellent machinability. So from spheroidized annealing we get soft gel and with excellent machinability. Then we have full annealing, which is applied for hypo and hypereductile steel. It reduces the hardness, it increases ductility, refined grain structure, and it gives the homogeneity and induces softness. So this is all about annealing and its advantages, and in this next class I will try to cover this iron carbon diagram. So thank you.